All right, everyone, welcome in. Um, Sorry for the redo. I went and I was just double checking the audio quality in my last stream, and it was absolutely awful. So, yeah, we're gonna redo, and I'm seeing how it looks and sounds right now. Okay, looks like it sounds all right now. Okay, because the way that I'm trying to do things now is I'm going to live stream uh, the lesson and then after that edit it because that just seems like it's going to be a little bit easier. And if anybody has questions while we're going through this, then I can answer those to the best of my knowledge. Once again, I'm not an IT expert, as you can very much see. Just setting up the stream has its difficulties. So yeah, so let's redo the lesson. All right. So I wanted to, with this lesson, touch back on the video I did with the bits of binary, right? Because explaining binary itself is an easy concept, but um, after doing a little bit more research, I found out that what I presented is pretty outdated. Um, so there's what's called character encoding. Character encoding is where we take binary, which is our ones and our zeros, and we put them into a byte, right? And if we saw the first video, a byte takes 8 bits, and that byte has its own value that corresponds to a character. And a character that I'm talking about is like our capital A, capital B, capital C, lowercase a, b, c, 1, 2, 3, exclamation point, all of the characters that you could imagine using while you're typing. In addition to that, those characters can be behind the scenes as well, which I haven't really studied too much into yet. But let's dig into it by looking at this table that I have. Transition over here. And also, let me make sure that Discord's muted. There we go. So we'll transition over here. And this is the ASCII table. So ASCII is outdated. And we'll go and do some math on that and see why. So, but just taking a quick glance at the ASCII table, you can see we have a lot of characters here. Um, and then a lot of commands as well. We have our punctuation marks. We have capital A through Z, lowercase a through Z. We have our numbers, things of that nature. But as I talked about in the first video, the bits of binary, that leaves us quite limited in regards to what we can actually represent. And if we take a look on the right side here, I have my handy dandy tablet. So our two options are either 0 or 1 for our bits of binary. And 0 was off and 1 was on, right? So with that being said, we have two choices with either on or off. And what a byte is you can have a 0 or a 1. And those choices can go down to creating our byte, which is 8 bits. So as you can see here, there's 8 of these. And that creates a byte, right? And if you're a math whiz, which I'm not, but I like to do math, and as you saw in the last video, I get things wrong, even though I like math. Uh, we have 2 to the 8th possible choices there, which is equal to 256. And how do we get that? If you're not a math whiz, let's just show what 2 to the 8th looks like, right? Let me get my eraser. That way we can make some space. So we have 2 to the 8th. which is just a matter of 2 times 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 2. So 2 times itself 8 times. And the way we got there is we have two choices, which are 1 or 0. So there's two potential choices. And we multiply that potential by itself 8 times. So 2 to the 8th. That's more what that means. And that is equal to 256 different choices. Well, ASCII worked really well at the very start of computers because we didn't need tons and tons of choices. We didn't have to do complex characters. And this is, ASCII stands for the, I'm drawing a blank now. The American Standard Code for Information Interchange. So America put this together, and we don't have like a lot of complex characters that we needed to use back then. And as the world starts to evolve and get more technological, well, we need more characters. Japanese, for example, has over 2,000 kanji, and then like I think it's like 40 hiragana and 40 katakana to make like its whole alphabet of well over 2,000 characters. And you can see how ASCII itself will greatly limit what they can type out. And then you have like Latin characters like, the A with the fancy mark over top of it, and so on and so forth. And then you have characters like alpha and beta and gamma that are used in math. So you can see how ASCII, after some time, it started to become outdated. And the newer and most commonly used protocol now is UTF-8, which I haven't done a lot of research on. I was just reading about it with Coursera the other day, and I haven't gotten very deep on it. But what UTF-8 allows us to do is add more bytes for our character encoding. So we'll see how that works out here in just a second. So let's backtrack. When we're talking about ASCII and character encoding is just a fancy way of saying we have a value that is equal to a character. Let's look at capital A on my table here. See if I can't zoom in. There we go. Made it nice and big. So capital A, we see that it has the decimal value of 65, right? I haven't got into the hex characters, not quite sure yet, but 65 is in the table. And the way that binary works out, if we're looking at the right side of the screen now, is that from left to right, each bit section of this byte, so this whole thing right here is a byte, right? There's 8 bits in it. 1, 2, 3, 4, 5, 6, 7, 8, right? We have 8 bits. And these 8 sections here can be either 1 or 0. Let me get my eraser. So these can either be 1 or 0. And what happens is when the value for the byte in this bit location is indicated as on, that number is added. So we have 128. And if the value is off or 0, it's not added. And then if we turn it back on again, we add. Off we ignore, off we ignore, on we add. And that's how we get up to our value. So what does A look like? We're on capital A. So capital A has a value. Let me figure out how to zoom back. Zoom back a little bit more. Capital A has a value of 65. So we need to ask ourselves, from left to right, how can we add up to 65? Well, 128 is over 65, so we're going to turn that value off. 64, yeah, that definitely goes into it. And as we're looking from left to right, to get up to 65, we just need 1. So we'll turn the value on for 1 and 64. And we'll turn the rest of the values off. All right, so what we're left with is 0, 1, 0, 0, 0, 0, 0, 1. And that just breaks down to 64 plus 1 equals 65. So if we type the character capital A, the binary code 01000001 is what is sent to register that capital A. It's sent to the table, which sees that we're adding up to 65. And then the table inputs the character capital A. Let's see. There we go. We can go back to normal now. All right, let's do a few more examples just for funsies. Let's make the word hello, right? So we need capital H, lowercase e, 2 lowercase l's, and then O. So let's look at capital H. Where are we at? We're at 72. So we need to create the value 72. Double check. All right, let's see if my math is on point, because in the last video, that was embarrassing. It was not. So 128, we'll turn that value off. 128 exceeds our value. 64 is definitely in there. So we have 64. And we can make this easy. Let's do this by the numbers. Let's go back. So we'll do 72 minus 64. Let's see, 12, 11, 10, 9, 8. That's 8. 7 becomes 6. So now we need to get a value of 8. So we'll go over to 8 and turn that value on. And the rest of these values we can turn off. All right. Get my handy dandy eraser. So we needed to get to our value of 72 for our capital H. And we are left with the binary sequence of 0, 1, 0, 0, 1, and 0, 0, 0. So this is our first one. 1, 2, 3, 4, 5, 6, 7, 8. Sweet. We have the byte of capital H right here. All right, so now we need to go to lowercase e. Where are we at? So lowercase e, we are at 101. That's the value we need to get to, 101. So 128, too big. We're going to turn that value off. Let's go to 64. All right, we can use 64. We'll turn that value on. 64. Let's see, 11, 10, 9, 8, 7. I don't know why we're doing that. And then we'll do 10, 9, 8, 7, 6, 5, 4, 3, 37. Does that seem right? Yeah, that looks right to me. So now we need to get to 37. Well, 32 goes into there. And then we're left with 5, which would be 4 and 1. And we can turn the rest of these values off. Let's get our handy dandy eraser and clean this up a little bit. So for lowercase e, we're left with the byte for 101 is 0, 1, 1, 0, 0, 1, 0, 1. That is our byte for lowercase e. Well, now we need lowercase l, which is 108. All right. So once again, 128 is too big. We'll turn that off. We'll do 64. So now we need to get to 44. We'll do 32. And now we need 12. So we'll do 8. 8 and 4 is 12. And we'll turn the rest of the values off. All right, so for lowercase l, we needed a value of 108. And we have the byte of 0, 1, 1, 0, 1, 1, 0, 0. Well, we don't need to do that again because we're just going to be repeating this. And let's figure out O. Let me clean this up. So for O, we need 111. All right, so 128, once again, too big. We'll go 64 and 32, which is equal to 96. Let's see. 11 plus 4, 15. So we need 15 more. 16, unfortunately, is too big. So go 8 and 4. That'll be 12. So we need 3 left. And that's what we have. So for lowercase o, we needed a value of 111, and we are left with the byte of 0, 1, 1, 0, 1, 1, 1, 1. And once again, this is just reference the ASCII table. This is the older method that I was learning about with Coursera. In Coursera, I definitely recommend checking out, and we'll check it out in just a little bit, just something brief. But another concept that Coursera was talking about is the idea of abstraction. So abstraction itself is just a matter of taking very complex things, like what we're talking about right now. We're taking a complex idea and we're simplifying it, right? Same thing with coding. Coding is extremely complicated, but when you go and you look at a website, everything looks very easy and appealing to the eyes. So that's what abstraction is taking a complex idea and simplifying it. So we're taking the complex idea of like what's running behind the scenes for like the binary byte of lowercase o, and we're making it a lot easier to understand by the computer processing it, referencing this table, and then when we type that lowercase o, that's what appears. So if we were to type out the word hello in binary, let's go back and take a gander of what that looks like from start to finish. So we can start up here, and let me get a sticky note going. That way it's a little bit easier to read. All right. Fortunately, I can't type it out any bigger, but all right. So we're going for our hello, and our capital H was 0, 1, 0, 0, 1, 0, 0, 0. All right, so that's our capital H. Then our E is 0, 1, 1, 0, 0, 1, 0, 1. Then our L was 0, 1, 1, 0, 1, 1, 0, 0. And then we do that again, 0, 1, 1, 0, 1, 1, 0, 0. And then our O, which is 0, 1, 1, 0, 1, 1, 1, 1. So if you're playing Helldivers, you would see that if the bots were trying to be nice and friendly, they would probably say something to the effect of this or send this to you. And maybe that's because they're trying to optimize their data transfer and maybe processing power, because if you don't have to reference the ASCII table, then maybe that increases your processing speed a little bit. Who knows? All right. But yeah, that's what I have for binary and character encoding. I'm going to do some research on UTF-8 and get back to you guys on how that actually works out, because I did a little bit of ChatGPT and fooling around with it, but I couldn't really grasp the concepts yet. So once I fully understand that, then I'll reach back out on YouTube and try to do a video on UTF-8, and we'll go from there on that. But this, as far as I've come to understand it, is how character encoding works with ASCII, which is the older method. And I think starting off from the very basics and then building our way up is probably the best way to go about learning IT and getting into IT, because it's just overwhelming, the barrier of getting in there. And I think when we can break these things down into bite-sized pieces, do you like that? Then it makes it a little bit easier to comprehend. But genuinely speaking, there are some really, really good resources out there. And I wanted to show you guys at least what it looks like. I'm not going to demo the lessons, I don't think. I have to do some more research into like copyright law. But I think I can just show you what it looks like briefly. Let's see. So this is just like how the modules are laid out. This isn't going into anything deep. And the way it works out is like, you can see here how we have like some videos, and then there's reading, and they break stuff down into easy to understand chunks. And this is Coursera, which is about $50 a month. And I'm working through this. And in addition to that, I'm working through the CompTIA. Now, if you pay for everything that goes with CompTIA, it seems like it's pretty pricey, like around that $1,300 to $1,500 range for the learning material. I just paid for like the basic learning material, if you would, which has some videos and has some reading that you can do. And I've done a little bit of it, but I'm only like 3% done. And yeah, it breaks things down into really good stuff. Like it starts off with like the, understanding that your help desk position or your IT support specialist positions, like it starts off with customer service, and it breaks into like troubleshooting methodologies, and then it starts to get into the nitty gritty technical stuff. And I don't know if you guys are like me, but I was also going through and like, learning ahead of class by like, oh, let's check out the test questions. And there's some YouTube videos out there on the test questions that they ask. And all I can really tell you is make sure the thing's turned off before you tear it apart based on that. But yeah, that's what I have today. Let's double check our notes. I mean, we're going to be here anyway, so let's double check my notes, and I'll bring my notes back up. Yeah, that was also a fun thing, is trying to figure out how to stream my tablet, going into like developer options and downloading strange things off the internet. But yeah. Hmm. I think that's a good thing too to touch on, is like understanding like what is a computer. Uh, Very basic idea, like what is that? And I think at the easiest level to understand, a computer is a thing that can store data and process data by doing calculations. And it gets a little bit more complicated than that. As I was reading through a little bit later, oh, that's another cool thing is like your display. You have to think about the fact that each and every one of your pixels needs to be told what color to become, right? And that has to be encoded. Uh, just that, having my video game playing, like it's kind of a wild idea thinking about how many calculations and processors done per second in order to render one pixel of color in one specific place, let alone like the 3D modeling that goes into effect. But just the idea of having a picture and putting a picture up on the computer, it has to process and tell each pixel what color to turn. So I think that's very interesting. And I started to do some research into logic gates with the Coursera. That'll probably be a video for a different day because logic gates are very important for helping a computer to make calculations and where to send different types of data as well. So we'll break into that in another video as well. But I hope you guys enjoyed it. And after this, I'm going to sit down with my brother and like do some gaming. It was a long week last week, and I need to do some decompressing. So if you're up for it, join us for some Icarus here in a second, and I'll catch you in the next one. Have a great day.